Howdy, I am Taylyn Sullivan, and this is my submission for the Biofuel project. And the biofuel that I chose is Biobutanol. So what is Biobutanol? Biobutanol is a 4-carbon alcohol produced from corn grain, sugarcane, switchgrass, and other agricultural byproducts like corn stalks and straw. This fuel gets its name from its sister fuel, butanol. These two fuels use similar biomasses as a source, but only biobutanol comes from the renewable biomass via fermentation. So as you can see here, we have our inputs for this, for our biobutanol. We have crops, food waste, other non-food resources, as well as the microbial source for our fermentation. And through this process, we get biobutanol. Technology of biobutanol. Biobutanol is created using acetone, butanol, and ethanol fermentation, or ABE fermentation. This process uses bacteria to convert sugars from biomass into acetone, ethanol, and butanol. This product is distilled and refined to isolate the butanol from the fermentation mixture for its use. Other tech, like genetically engineered bacteria and alternative catalysts, are used as well for a higher yield and efficiency of biobutanol. So here we have a little structure to show you the process. We have our biomasses over here, which are processed into just their sugar components. And then via fermentation, we have the production of our A, B, and E. So the pyruvate that goes through produces acetocoenzyme, which is added, acetic acid is added to that to create our ethanol. And then we have another coenzyme later derived, which creates our acetone and more carbon dioxide as byproducts of this process. And then butyric acid is added to create our final coenzyme, which later leads to the creation of butanol. Implementation of biobutanol. The main implementation of biobutanol is its uses in transportation, chemical solvents, and feedstock. Biobutanol can be combined with gasoline to make a more sustainable fuel source. When used as a solvent, biobutanol can help make paints, coatings, and resin. Biobutanol's feedstock use is similar to this because it is used as an intermediate for processing other chemical products. The pros of biobutanol. Biobutanol has a higher energy density than ethanol. This means that less fuel is needed for the same energy output. It is compatible with existing infrastructure because biobutanol is less water soluble. It can go through existing pipelines and does not need specific ones to go through and be distributed at a lower percentage or concentration. It is less corrosive, especially compared to ethanol, which means this reduces the potential damages it may have on infrastructure. It does have a lower vapor pressure and emission, which means that there's lower evaporative emissions, causing less hot start or spark start problems in engines, as well as it being a domestic and renewable production process. It can be produced with renewable feedstocks, which is the main goal, and create a lot of domestic jobs. The cons of biobutanol. It is high to produce, has high production costs. The production costs are higher than other biofuels, as well as biobutanol being an early industry, meaning that there is not a lot of support monetarily yet for this production. It does have a lower production yield. It yields lower than bioethanol from this fermentation of ABE. It also has a higher viscosity, which can cause corrosion and degradation of spark engine performance because of how viscous it is. Its compatibility is slightly low. Any higher concentration or blend higher than 15% may require engine modifications to be useful and not damaging to the engine. And limited infrastructure. There's limitations of dedicated infrastructure for these high concentration or high percentage blends because it is such a early industry. Well, that is it, guys. Thank you so much for watching, and I hope you have a blessed day and got to know more about the biofuel that is biobutanol. Thank you.